Bennett Fitch here, and welcome to another Noria unboxing. All right, guys, we're gonna be checking out this AMETEK Spectro Scientific FieldLab 58C. Now, this is the flagship solution for their FieldLabs options out there. You might remember the FieldLab 33 that we did an unboxing about a year ago. This one's definitely different. It focuses more on particulate and other wear metals that we want to address in certain types of environments. So we'll get into that, along with some other changes here. So if you could definitely check out that video along with some of the other AMETEK Spectro Scientific unboxings we've done, like the Spectral, the FaroCheck, and the Fluid Scan. So let's get into this. All right, so this technology has the ability to look at all three key areas of oil analysis. That's going to be wear debris, contamination, and fluid chemistry. So with wear debris, we can definitely pick that up with the XRF, which is X-ray spectroscopy technology. We're also able to look at the chemistry with a few things here, but one of them is the viscosity with the SpectroVisc and the Fluid Scan, which looks at other things related to the lubricant, including oxidation, nitration, and a few other things. And I'm going to show you how easily that all gets integrated in here into 4 different modules and all connects together. Everything here follows ASTM procedures to make sure we have good consistency and make sure the accuracy is in check. So of course, oil analysis and building an oil analysis program is well understood as part of a larger lubrication program. A lot of industries already recognize that with other condition monitoring. This has been designed to answer the needs for those industries where you need to make quick decisions. You're not able to wait a little while for that data to get back from the laboratory. And the critical aspect of the key machines you're working with can't wait that time. You need decisions made within minutes. We can get those answers here within 5 or 10 minutes. So that's what this FieldLab does. It gives us a chance to look at important parameters, conditions of the oil, like viscosity, like oxidation, things that could tell us the oil is failing, or conditions of the machine, or even maybe contamination. Contaminants are getting to the oil. That could be an early indicator that if you don't do something about it now, it could lead to a failure in the near future. All right, so the first thing I notice is how well it's built. It's rugged, it's designed for the environments that this is in, maybe in a mining environment, maybe in an offshore rig, maybe in power generation where there's a lot of contaminants, and where you're storing it could also be in a tougher environment. And just as we were kind of opening it up and having things on display here and ready to use, it was very well built, held together very well. So that's really important when you're thinking about its use. Another thing is the power. So I was even able to turn it on without it being plugged in or anything. I went ahead and plugged it in, but I didn't need to. This has 2 to 3, 4 hours of battery and can easily suffice for what you need in your environment. Now, if you know oil analysis, sometimes you take a sample and a sample bottle, it's 100 milliliters or so. This only needs about 12 milliliters to perform all of the tests, and you can do all that within 10 minutes. So think about all that opportunity and what I just talked about, how long it takes the week after week to get the data back from a commercial laboratory. So in the right environment, if you need data fast, and it's very beneficial to take corrective actions, what's needed next, proactive needs, that's important here. So here we have a few things. We have the Fluid Scan, which is looking at the molecules. Molecules of the oil that could tell us a bit about oxidation, nitration, sulfation. There's also a way to indicate the acid number or base number of the oil. Even water content can be detected with this because we're looking at H2O, which is water, of course. That's a molecule of water. The next thing here we're looking at is the mini-visc, which basically it's a kinematic viscometer, but it uses a special patented technology here. It's going to measure with sensors how long it takes the oil to go down, and it's temperature controlled, so that's an important thing to control as you measure viscosity, and it's seeing how long it takes by gravity for it to get from one point to the next. So that's kinematic viscosity, the most important physical property of the lubricant. Now think about this. There's a case example with one of these being used where someone was using it and determined on a new engine that was installed that the viscosity, which should have been more like 120 centistokes, was actually 70 centistokes. And that big difference there is considerable when you think about the protection that oil needs to have on that engine. Because of this, they were able to detect there was a viscosity change, and through further testing, including what was on here on this instrument, they were able to detect that diesel fuel got into the engine oil, and they further investigated where the source was, and they corrected the issue. So that's a case example where something like this can give you data fast. If they were not able to get that data within the weeks after with a commercial laboratory, it could have been too late. The next thing here we're seeing is two things on this side, and it takes what they put together on a patch and lets you have that later on for observation, including XRF. That's X-ray fluorescence, which basically is letting us look at a number of elements, 16 elements that we're looking at here. Those are all elements that could be related to contamination. It could be related to wear debris. Now, wear debris is very important because if we're already in a state where we are seeing that the wear corresponds to a failure in progress, then that's a concern. So this approach to elemental analysis with X-ray technology is actually addressing what traditional elemental analysis sometimes misses with larger particles greater than about 4, 5, 6 microns. You might see that on a patch or with particle counts, but you don't see it there. But XRF can, because it's also looking at things on a patch. Okay, so let's take, we took an oil sample just now and we need to run it through the lab here. This FieldLab will give you a chance to do it pretty quick, like I said, about 10 minutes, and it comes with a few different things. One thing for sure that you're going to need is a little pipette like you see here. This will be important for the fluid scan and the mini visc. So you're just gonna add a drop or two of oil for each one of those, and it's a quick process. Once you get the pipette here and add a drop of oil, it runs the test, and when you're done, you clean it off with a little rag like this, a little cloth, no big deal. It all takes within about a minute or so. Same thing with the mini visc. These two, along with the XRF and everything else you see, is all following ASTM procedures, and it helps with the accuracy behind the data, just like you would in a commercial laboratory. So you can kind of feel confident with that kind of approach. But over here, this will be the XRF, and it's going to do that by preparing a filtergram. A filtergram is basically a filter patch that will collect the debris as you push oil through it. Now you're gonna push oil through it with a syringe, you're gonna collect some oil with a syringe, and once you do that, you're going to place it in there. Before that, you wanna make sure you put your, this is the filtergram. You place that here at the bottom, push that down. Let's say you have oil in here, place in here, and then you let it run the test. It's gonna push oil through, it's gonna prepare that patch, and then you can take this out and put it in this next area over here. This is the XRF on this side that'll collect all the data related to 16 different elements. Those elements include iron, include aluminum, include silicon, chromium, tin, and several others. These could correspond to contaminants. So that might be aluminum again, because that's one of the common elements, including silicon, that you're going to trend over time to see if contamination is in there. And also could be wear debris. So once again, this technology with XRF is focusing on wear particles and contamination even greater than 4, 5, and 6 microns. Now what that means is that if you have a severe wear event, then you're able to detect that more easily. Prior to this, you might just look at particle counts and then try to correspond that in other ways with other concentrations. But this can look at those elements that are even larger that correspond to severe wear events, and that gives you a window into what's happening inside the machine. So they provide you everything you need. There's even some verification fluid here to kind of calibrate as needed throughout various stages of utilizing this, but it's all really nice and compact. So as you look at all of it here, everything is pretty straightforward. Watching a couple quick tutorial videos will give you a quick idea on how to use it. It's actually pretty intuitive. You kind of play with it a little bit, you'll notice how everything works. And once you see the data, the whole goal here is to be able to take very decisive action on what needs to be done with your machines. So that what shows up on the screen here gives you alerts, gives you data on when things are out of limits compared to the baseline sample. It lets you trend the data over time, just like everything you may be already familiar with on how important oil analysis as a condition-based maintenance solution can provide you the much needed information on whether or not your machine is in a state of failure or leading towards failure. Or hopefully not, and everything's fine, and it gives everyone that assurance that everything is good. And of course, you want to help avoid costs in the future with unnecessary changes of oil or unnecessary changes of parts that can be avoided and delayed with understanding from the oil analysis. Okay, so I hope you learned a few things here about AMETEK Spectro Scientific's FieldLab 58C. Now again, this is one version. They have a few others, so definitely check it out and see which one might be best for you. If all this is a little overwhelming, when you get this, they provide a whole bunch of tutorials and different kind of user guides through their Fluid Management Academy. That's great for even understanding how to interpret the data, how to know what next action needs to be happening with your machines. And it's very specific to whether it's an engine or a compressor or a turbine, all important for you to understand how it makes sense for your equipment. So thank you for watching today. We hope to see you in the next Nori unboxing video. And for more information on this, check out the link below.